So today we're looking at factoring trinomials using a method we call the X in box method. Now some of these problems will be a carryover from what we've done previously, where we've been factoring by grouping, or like this one on number 7, where that's a difference of perfect squares. So some of them will have patterns that should look familiar based on what we've seen before. However, when we have a trinomial, there may not be a clear-cut pattern. Sometimes there is. But most of the time we solve with a guess and check approach. And you can certainly do that here. In fact, it will factor very quickly with a guess and check. However, I'm going to use this problem to show you a different method we call the X in box method. And the reason I'm showing you is so that when you get to more complicated problems, like down here on number 9, when your leading coefficient is not 1, well, it's a lot harder to guess and check, and we need a system to take us through the process. So I'm going to introduce the system to you with an easier problem before we get to a harder one, and we'll do a couple of these as well, okay? So, yes, you can guess and check, but what if you can't guess and check, then what? That's what this is all about. This is really just a way of factoring by grouping. It's a slightly different setup, and so we're going to first of all identify our coefficients. So the coefficient on the leading term, in this case, is just a 1, so we call that an A. On the middle term is a B, and then we have our constant term. So we're going to set up the X part of this, where we are multiplying the values of A times C and put that at the top, and we'll take the value of B and put that on the bottom. And so we end up with a negative 15 on the top and a negative 2 on the bottom. Now we are still guessing and checking because we have to guess two numbers that will fill in the sides that when you multiply them together, they will multiply to a negative 15, but when you add them together, they will add to a negative 2. So with the negatives in there, we have to consider factors of both positive and negative. So factors of 15, 1 times 15, or 5 times 3, we like 5 times 3 because we can find a way to put a negative sign on this that will result in adding them together to get a negative 2. So we want the negative on the 5 and a positive on the 3. So yes, we still have to do some guessing and checking here, and if you want to use your calculator to help you find those factor pairs, that's totally fine. But once we get to that point, everything out here is just pure procedure. Now the concept here is we're taking the middle term and we're throwing it out. Goodbye, x squared, you are now gone. We're replacing that term with these two. So this negative 5 is really a negative 5x squared, and this positive 3 is a positive 3x squared. So we really have 4 terms because we threw out the middle term and we are replacing it with these two. As a way of organizing it, this is the box part of what we're calling this method. And so we're going to put those 4 terms in the 4 cells of this box. So the first term goes in that top left corner next to the fourth. The constant term goes in the bottom right. So there's your first, there's your fourth. So the second and third will go here. And it does not matter which goes where. So you could put the negative 5x squared in either cell. I'll just drop it here at the bottom. So negative 5x squared and a positive 3x squared. Essentially, we are factoring by grouping. We're just grouping them up in this little table. So you want to look at the top 2 terms and identify the common factor. They both can be factored with an x squared, and you put that here on the outside on the left. So now we're going to figure out what goes on the top, and ask yourself this question. X squared on the left times what value on the top will give you a result of x to the 4th. So what you're thinking of is these are the things that have to be multiplied together, and what's inside the cell is the answer. So again, x squared on the left times what value on the top must multiply to get you an answer of positive 3x squared. So we need a positive 3. So keep the sign with the number because this is going to be one of your solutions. Looking at the column on the left-hand side, what value on the left times the x squared at the top, multiply to get a negative 5x squared, that's a negative 5. Now double check your work. Does negative 5 times the positive 3 multiply to that negative 15? If it does, everything is good, and these are your factor pairs. So the original problem factors into x squared plus 3 times x squared minus 5. All right, so again, it doesn't matter if the factor is in front or in the back. The order of the factors does not matter, but those are the 2 factors. Now that's a lot of steps, so we'll be going through it again here a couple more times. And again, with a problem like number 2 with a leading coefficient of 1, it would be faster to guess and check, for sure. So if you have a problem like number 5 and you can guess and check, go right ahead. But if you're not sure how to guess and check, this at least gives us a system to go through. So let's look at number 9 next. Here we have a leading coefficient that is not 1. So that makes guessing and checking a lot more complicated. So we're not going to guess and check, we're going to use this X in box method. So we have a leading coefficient of 2, we have a coefficient on the middle term of 1, and the constant term is -6. So here we are setting up our X. Again, we want the A times C at the top and the value of B at the bottom. So 2 times -6 gives us that -12 at the top, and then just a +1 at the bottom. So this is the only point now when we really are guessing and checking what two numbers will multiply to the -12, but when added, will add to a +1. So our factors are 1 times 12, 2 times 6, 3 times 4. We want the 3 times 4, and we have to figure out the negative sign here because they have to multiply to a negative sign. So does the negative go on the 3 or on the 4? We want them to add up to a +1, so we want the positive on the bigger number and the negative on the smaller number. Again, what we're doing is we're throwing out that middle term of x squared, and that means these are my other two terms, -3x squared and +4x squared. Now we take it to the box. My first term of 2x to the 4th goes in the top left corner. My constant term goes in the bottom right. The other two terms go in the other two cells, and again, it doesn't matter which one goes where. So if I took this -3x squared and I put it up here, that's fine. I can put the +4x squared on the bottom. There we go. So now we're going to factor by grouping, and we're grouping up those first two terms, those top two terms. So what is the common factor? You have to look at both the coefficients and the variable as well. So once again, we have a common factor of x squared. So we ask ourselves, x squared times what value at the top results in 2x to the 4th? We need a +2x squared. For the next column, we need x squared on the left times what value at the top gives us an answer of -3x squared. We need a -3. Then we're looking at the left-hand column. What value on the left times the 2x squared at the top gives us that answer of +4x squared. I need a +2, right? So again, keep the sign with the number because that will be one of our answers. And then check your math. +2 times -3 gives us the -6 that you see in the cell, and yeah, we're good. So our solution is 2x squared minus 3 and x squared plus 2. So that's the factor pair that came from the original problem. Let's go to number 10. We'll do another one here. So again, we have 2x squared minus 13x plus 20. So identify your A, B, and C. And we'll set up that x. Again, we want A times C at the top. So 2 times 20. And the value of B at the bottom, -13. So we want to think of two numbers that will multiply to +40, but when added, add to a -13. So because they're adding to a -13, we know that these have to be both negative. So they'll both be negative so that they multiply up to a +40. So factors are like 2 times 20, but that doesn't add up to the 13. Right? 4 times 10. We want 8 times 5. 8 times 5 is 13, but they both have to be negatives. So again, we're throwing out that middle term, which is in terms of x, which means these new numbers have to be in terms of x as well. So that first term of 2x squared goes on the top left, the +20 on the bottom right, and we have a -8x and a -5x for the other two cells in the grid. Let's identify our common factor here at the top. They have a common factor of just x. Okay, so what times x is 2x squared? We need a 2x. What times x is -5x? We need a -5. What times the 2x is the -8x? That's a -4. And then check your math. Yes, they multiply to the +20. So that means our solution is 2x minus 5 times x minus 4. So we've just seen those three examples, taking you through those steps. And while there are other ways to factor it, I'm just showing you this particular method here. Before we finish up, let's do one more. Number 12. Number 12 is really hard just because the numbers get so big Let's just work on it together. It's still the same method that we're going to use, but you'll see that we have much bigger values. And to help us out, we'll need our calculator. If you happen to have a graphing calculator, I'll show you a trick to help you find those factor pairs. That'll be extra handy, so keep that nearby. So to begin, we're identifying the values of A and B and C. And in setting up our x, again, we want A times C at the top. Well, 4 times 225, right? I need my calculator to figure that out. That's pretty big. That'll turn out to be 900. And then the value of B at the bottom, we have a negative 61. This is where we're stuck, right? Because we still have to guess and check. How in the world do we figure out two numbers that will multiply up to 900, but at the same time will add to a negative 61? Now again, because they have to add to a negative 61 and multiply to a positive 900, we know that their values will both be negatives. We just have to figure out what those numbers are. And there's lots of factor pairs of 900, so to make our job a little bit easier, we'll get a list of them going here using the equation editor. So what I'm doing is I'm hitting the y equals button as if I were to graph it. I'm not going to. And what I'm going to type in is I'm going to type in the number I want to factor. I want to factor the 900, so we'll type in 900, and then we'll divide that by x. That is telling it to run every possible division, every possible factor pair. So that's going to be my 900 divided by, and the x button is right here. That's the variable button, right next to the alpha button. So there it is, 900 divided by x. Now I'm not going to graph it. I'm going to look at the table. So right above that is the table function. So second function table generates for us a whole list of numbers, as you can see here. And let me just scroll back closer to values of 0. So look at this. Here are your factor pairs: 1 times 900, 2 times 450. And as you go through them, you're asking yourself, okay, does that add up to 61? How about 3 times 300? Does that add up to 61? No, of course not. What about 4 times 225? So this generates all the factor pairs. If you see a decimal value, ignore that, because that's not a factor. It's just dividing by 7. We want to look to see where it divides evenly. What about 9 times 100? Does that add up to 61? No. So you might have to scroll down a ways, and that's what we have to do here. There's a factor pair of 12 times 75. Does that add up to 61? No, it's still too big, so let's keep on going. There's a factor pair of 15 times 60. Does that add up to 61? Nope. Keep on going. All right, so it's going to end up being this factor pair right here. 25 and 36, they add up to 61, so we will have those values. So it's a negative 25 and a negative 36, because they'll multiply to a positive 900 and they'll add up to a negative 61. So again, we're throwing out that middle term, so that x to the 4th is what we need to use here on both of those values. So as we set up our box, we're going to need a bit more space down here in the coming steps. So I'm trying to squish it down a little bit to fit in the space. My first term is 4x to the 8th. The last term is the 225. These can go in either cell, so here's a negative 25x to the 4th and a negative 36x to the 4th. So we have some pretty big values here. We want to see what is the common factor. We have to check both the coefficients and the variables, and I can factor out a 4. I can also factor out an x to the 4th. So we have 4x to the 4th. That's my greatest common factor. Here on the top, I will need something times the 4x to the 4th to get me a 4x to the 8th. We'll need an x to the 4th. Remember, when multiplying those same bases of x, you add the power. So 4 plus 4 gives us that power of 8. Again, 4x to the 4th times something has to give me a negative 36x to the 4th, so I need a negative 9. On the left-hand side here, something times x to the 4th gives me that negative 25x to the 4th. I need a negative 25. And then we check to see if that multiplies to the 225, and it does. So that is our factor pair. So we have x to the 4th minus 9 times 4x to the 4th minus 25. Now we found our factor pairs, but we're not done because these are patterns we've seen before. These are the difference of perfect squares. So each of the factors are in fact the difference of the perfect square pattern, and so we can factor them again. So the first one turns into x squared plus 3 times x squared minus 3, and the next one becomes 2x squared plus 5 and 2x squared minus 5. Those cannot be factored any further, so that's our final solution. We end up with 1, 2, 3, 4 factors.